Okay, so for lesson 5.4, we're going to be talking about something called a mid-segment of a triangle. So this is a new vocabulary term, but I think this one is a little bit easier to understand than the previous ones we've covered in this chapter. So I'm going to start with a definition. A mid-segment of a triangle is a segment that connects the midpoints of two sides of the triangle. So a mid-segment connects the midpoints of two sides of a triangle. Every triangle has three mid-segments, and those three mid-segments form what's called the mid-segment triangle. So in this triangle ABC, the mid-segments are MP, MN, and PN. They form triangle MNP, which is what we call the mid-segment triangle. So the mid-segments are half of the side that they are parallel to. So if we look at this mid-segment MP, it is 1/2 of AC. Okay? If we look at MN, MN is 1/2 of BC. Right? And then if we look at NP, that is 1/2 of AB. And those segments, MP and AC, are parallel. MN and BD are parallel. NP and AB are parallel. So we're going to use an example to show that a mid-segment is parallel to a side and that it's 1/2 the length of the side. So first, to prove that they are parallel, you just find the slope of both of them. So slope of MN. Okay, the slope of MN, I go down 1, right 1, 2, 3, 4. So the slope is -1/4. Okay, slope of MN is -1/4. Then I'm going to find the slope of JL. So the slope of JL, I go down 2, right 8. So -2/8, which is -1/4. So by showing that the slopes of those segments are the same, or that they're equal, we showed that those segments are parallel. Okay, the mid-segment MN is parallel to JL. The other part, showing that MN is 1/2 the length of JL, we've got to find the distance between M and N. So I'm going to do a quick reminder that the distance formula, which we've done a while ago, but we're going to come back to it, x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to find the length of MN. So MN, if we look at those points, M is the point -4, +3. Okay, M is -4, +3. N is 0, 2. So if I do x2 minus x1, that's 0 minus -4 squared. Okay, x2 minus x1, and then y2 minus y1 would be 2 minus 3 squared. So this really becomes the square root of 4 squared. 0 plus 4 is 4. So that squared is 16. And then 2 minus 3 is -1. -1 squared is 1. So I'm just going to leave this as the square root of 17. Okay? The square root of 17 for the length of MN. I do the same thing for the length of JL. The square root of, and just the points are given to us for JL. So if I do x2 minus x1, that would be 2 minus -6 squared, plus y2 minus y1 would be -1 minus 1 squared. So what this would be is the square root of 2 minus -6, which is 8. 8 squared is 64. 64 plus -1 minus 1 is negative 2. Negative 2 squared is 4. So this is the square root of 68. Okay? To prove that mn is half the length of JL, I would just take the length of JL, square root of 68, divided by the square root of 17 to prove that that really is 2. If I divide the longer length by the shorter length, it's 2, which means mn is 1/2 of JL. I'll do that a little bit better. So it's kind of a lot of work for one problem. Now, we're going to practice this next time. I'm going to go through more examples of this next time to make you feel more comfortable about finding the length of something, about finding distance, because this distance formula is not going to go away. Now, there's going to be times where I let you reference it, but I do want you to remember how to use the distance formula to find lengths. So in part one of this example, I do want you to try this on your own as a little bit of practice. So use that last example as a guide. And I just want you to do number 1 for right now. So just work through number 1. Prove that they're parallel. Prove that DE is 1/2 of AC. So pause the video. Once you're ready to resume, you can check your answers. I'll go through number 2 with you. Just focus on number 1.